Hi everyone, welcome to GoClasses. So in this session we will discuss detailed solutions of All India Mock Test 2 by GoClasses. So today we had All India Mock Test 2 AIMT 2 and the response is excellent, so thank you for that first of all. And many students we were basically we asked for feedback about AIMT2 and we got excellent feedback, and also we were asking you whether you want another mock test or not, another all India mock test or not. Okay, so you can put your comment on the Go Classes YouTube channel. We have put one feedback video. Okay, so this feedback video you will find on the Go Classes YouTube channel, so please go there and comment your feedback. Do you want another Go Classes all India mock test? Okay, Go Classes AIMT3 do you want? Okay, so please comment on the feedback video. That feedback video you will find on the Go Classes YouTube channel. Just find it and put your comment there. We will consider all your comments and then we will decide whether to conduct another all India mock test or not. Okay, so the response so far is amazing, and please share your feedback with us. Okay, so now let's start the detailed solutions of this AIMT2. Let me introduce myself. My name is Deepak Poonia. I have completed my MTech from Indian Institute of Science IISc Bangalore, and many times I have secured top rank in the GATE exam like All India rank 53, All India rank 67, 206, 256, etc. Okay. Also, All India mock test. This link you can find in the description. Okay, this link mock test 2. As I told you, this mock test 2, this link you can find in the description, so you can check it out. And if you want to attempt all the Go Classes and GATEOverflow mock test, okay, if you are loving the mock test, if you are loving the questions, the quality of the questions, if you are loving, then if you want to attempt all the 15 gate worthy, okay, good quality, best quality mock test, if you want to attempt, then you can subscribe for this package. This package you can subscribe. There is no need, you don't need to subscribe for the entire test series. There is no need. You can subscribe for this package. Okay, this mock test package you can subscribe. In this mock test package you will get total 15 best quality mock test you will get. Okay, so these mock test you can attempt before the GATE exam, and you can learn, you can improve, you can find out where you need to improve. Okay, so you can take your preparation to the next level by attempting these best quality, these GATE worthy 15 mock test. Okay, so now let's start now. All First, we will see the theory of computation questions, but before that, I want to discuss this aptitude question. So, this is a very nice question. Can you tell me, did you do it correctly? This question, look at this question and tell me, did you do it correctly? This question, let me know. So, let me know. Ratul is asking, what are the ideal marks for this test? So let me tell you that if you are getting more than 50 marks, more than 50 marks, if you are getting more than, okay, greater than or equal to 50 marks, if you are getting, then that is very good. Then, okay, that is very good. But it does not mean that if you are getting less than 50 marks, then that is bad. Okay, so don't worry about the marks. Just analyze the test and improve. Okay, just see where you were making mistake, in which concept you were making mistake. Okay, just analyze and improve. Okay, now let's see. So this question, this is a aptitude question. Now can you tell me what is the answer for this? Did you do this correctly? Now the question, let's look at the question. The question is saying that suppose a comma b comma c are statements. These are statements such that, okay, the question is saying c is true if exactly one of a comma b is true. Okay, what this question is saying? Question is saying c is true if exactly one of a comma b is true. Okay, so the question is basically saying that a exclusive or b implies c, because remember what this question is saying. The question is saying c is true if exactly one of a comma b is true. So this same statement you can rewrite. Remember, you can rewrite this statement like this. You can say that if exactly one of a and b is true, if exactly one of them is true, then c is true. Okay, so what this question is saying, this question is saying exactly one of them is true. If exactly one of them is true, exactly one means either A is true, B is false, or A is false, B is true. Exactly one of them is true, then C must be true. So you can see this is given to you. Okay, in the question, this is given to you that A exclusive or B implies C. If exactly one of them is true, this exclusive or, this is your exclusive or, this is your exclusive or, and this says that exactly one of them is true. Either A is true, B is false, or A is false, B is true. So this, now you can notice this is given to you. Now you tell me, now the question is asking, if C is false, then what can you say? Then what must be true? See, the question is asking what must be true. This is very important. The question is asking what must be true if C is false. So remember, this is your statement. So what will be the contrapositive of this statement? The contrapositive. The contrapositive. So what is going to be the contrapositive of this statement? For this statement, the contrapositive will be if C is false, if negation of C, if C is false, then negation of A exclusive or B. It means if C is false, then they will have the same value. Okay, A comma B will have the same value, right? Yes or no? So very simple, that if C is false, if this C is false, then they must have the same value. A comma B must have the same value. So I can say that if C is false, I can say if C is false, then what can happen? Then either this can happen. Then either this can happen, that either both A comma B are true. So they will be same. This is guaranteed. This is guaranteed. They will be same. Okay. So either they now I can say that they will be same, that is guaranteed, but you can also say that then this will happen. Either this will happen that both are true. Okay, either this is going to happen that both are true, or this is going to happen that both are false. Okay, but they will be same, right? Yes or no? Okay, they will be same, but either they both will be true or both will be false. So tell me one simple thing. Can I say options D is must? The question is asking for this. This is important. Please note this. The question is asking which of the following must be true. The question is asking which of the following must be true. Must be true. So tell me, can I say option D must be true? Tell me, A comma B are true. Can I say this must be true? No, this must, okay, because you can notice both may be true or both may be false. Either this will happen or this will happen. They will be same, but either both will be true or both will be false. So you tell me. So very easily you can see that here this statement is definitely false. So you can easily see if C is false, then they must have the same value. So this is also wrong. Okay, this is correct. This is also wrong. So answer is going to be option B. Is this clear? Let me know. Please tell me. Is this question clear to everyone? Let me know. The question, the explanation, is this clear? So very simple. The question is actually very basic question. The question is simply saying that, let me explain in another way. The question is saying that exactly one of A comma B true. Okay, then in this situation what will happen? In this situation C will be true. So you can see that if C is false, then this would happen. So what will happen? So this same thing you can say that if C is false, then this cannot happen. This cannot happen. Okay, so if C is false, then either both will be true. Either A comma B both will be true, or both will be false. But it cannot happen that they are exactly one of them is true. Either this will happen or this will happen. So what I can say? I can say that if C is false, then definitely A must be equal to B. This must happen. Remember, this must happen. But this is not but this is not must, right? Okay, this is not must. This is not must. Okay, this is not must. But remember, this must happen. This must happen. So that is the reason. Okay, clear? Okay. So you can see that the question is asking for must. What must be true? This is important point. Which of the following can be inferred? So you can see option D is false because it cannot be inferred. We cannot say that this must be true. Okay, so D may be true. Remember, D may be true, may or may not be true. D may or may not be true. Okay, so let's move on now. So this is a simple question. Tell me, did you do it correctly in the AIMT exam? In the AIMT exam, did you do this correctly? So this is a simple question. I think, in which category should we put? Easy or hard or moderate? So I think this is just analytical question. This is just small thing you have to take care. Very small things you have to take care. You have to take care that the question is asking for must. Okay, the question is asking for must, which must be true. Okay, very simple. GATE aspirant is asking in option B, A and B both false. No. The question is saying if A is false, then B is false. Option B is saying if A is false, then B is false. C. Okay, see what option B is saying. I can say that C is false, then if A is false, then definitely B will be false. Right? See this, if is important. If A is false, then B will be false. Definitely yes, they will be same. Okay, so that is the reason. Very simple. Okay, similarly, this option is also correct. If A is true, then B will be true because they must be same. So if A is true, then B must be true. Okay, so this is your question. Is this clear? Atharva, GATE 2023 aspirant, is this clear? So very simple question. Okay, so we Utsav and Akash are saying that we should put this in the category of easy. So you can see that this is an easy question. Silly mistake you did, right? Many of you did silly mistake. Those students who are answering D, who answered D, they are making this silly mistake. This silly mistake the students are making. Okay? Is this clear? This is just a silly mistake, nothing else. Because the question is asking for must be true. Now let's move on. Now let's see some TOC questions. All the TOC questions, theory of computation questions. Let's start with this one. Tell me the answer. Let's see this. What the question is saying. Which of the following languages is or are necessarily non-regular? Which of these languages is necessarily non-regular? Question is asking for non-regular. Which of them is non-regular? Okay, now you tell me. The statement 1, what the statement 1 is saying? Statement 1 is saying L is some given regular language. W belongs to sigma star. W does not belong to L. So what is this? Tell me. Statement 1. What statement 1 is saying? Statement 1 is saying that this is your language. Look at this. Like, look at this language M. And this language is something like this. W belonging to sigma star. Okay. Where W does not belong to L. Where L is regular. So what is this M? Can anyone tell me? What is this M? Anyone want to tell me what is this M? So you can easily see that in this M we have those strings which are not in L, right? We have those strings which are not in L. Those strings we have W, those strings we have from sigma star, those strings we have which are not in L, which are not present in L. So from sigma star, so basically in this, remember this is important that all the strings of sigma star which are not in L, all the strings of sigma star which are not in L. So I can say that M, this language is basically L complement, and regular language complement is regular, right? Okay, you know that regular language complement will be a regular language. So that is the reason this M is going to be regular. This will be regular. This will definitely be regular. The question is asking for non-regular. So this option A is not correct answer. Okay, what about this one? What about option B? Look at option B. Option B is saying that L is non-regular. What this option B is saying? Option B is saying L is non-regular. Now you tell me, if again you can notice M is L bar, right? Okay, M is L complement. This language is just L complement. What is the complement of non-regular language? Tell me, what is the complement of non-regular language? If you have a non-regular language, what is the complement of it? That will always be non-regular. How can you prove it? How can you prove it? Can you prove it? You can easily prove by contradiction. By contradiction, you can easily prove. See, The proof is very simple. This is the statement. I can say this is our result. Let me call it. This is our result that if L is non-regular, then I will prove what I'm going to prove. I'm going to prove that L complement is also non-regular. And what is the proof? The proof is very simple. By contradiction. If L is regular, assume L bar is regular. Just assume. By contradiction, you can prove. So if L is regular, if L is non-regular, assume for a moment, assume that L complement is regular. Then what will happen? Tell me. If you assume this, L complement is regular. Because L complement is regular, so its complement should be regular, right? So L complement, whole complement must be regular, right? L complement, whole complement must be regular. And what is L complement, whole complement? That is L. That must be regular. That is a contradiction. This is a contradiction. Why this is a contradiction? Because already given that L is non-regular. So this is contradiction. Is this clear? Very simple, cute proof, right? Yes or no? Very simple. This is a cute proof. This type of proof are called cute proof. Okay, very simple proof that if you assume that given this is given L is non-regular, this is given L is a non-regular language. Now, if you assume that L complement is regular, if this you assume L complement is regular, then what will happen? Then because regular complement will be regular, so L complement, whole complement, if you again do the complement, that must be regular. So L must be regular. So that is the reason. This is the contradiction, because it is given that L is non-regular. Okay, so this is the proof that non-regular complement will be non-regular. Okay, complement of non-regular language is non-regular. So definitely this is always non-regular. Okay, I can say option B is your answer. Option B is the answer that you are looking at. Okay. Yes. Now let's move on. Let's see option C. www belonging to 0 star. What about this one? www belonging to 0 star. See, what many students make the mistake. If you are by hearting the concept, now assume that you are by hearting the concept. Assume that you are by hearting concepts. Remember, by hearting concepts is a crime. By hearting the concepts is a crime. Okay, so if you are rote learning, then many students, what they do, because they are by hearting the concept, so they will say, okay, WW, okay, this is a non-context free. This is not even context free language. So this WW, this is non-regular. So this is non-CFL. So this is non-regular because WW is CSL. Right? Yes or no? So if you are by hearting the concepts, if you are rote learning, if you are not understanding the concepts, then what will happen? Then this type of mistake will happen. Because if you are rote learning that, okay, WW is non-regular, WW is CSL, it is context sensitive language, it is not context free. If you are by hearting like this, then remember, you will definitely make a mistake. You will definitely make a mistake. This is a mistake. Why this is a mistake? First you understand. Look at this language. W belonging to 0 star, unary alphabet. Your alphabet is unary. Look at your alphabet. Your alphabet is unary. W belongs to 0 star. So what is this language? Can anyone tell me? What is this option C language? In this language, what we have? We have W followed by W. Okay, means W. Let's assume this is W. Let's assume this is W. Let me assume this is W. Okay, then this is W. W followed by W. So you can notice that in this language, what you will have? You will have even number of W's, even number of zeros. So this is just even number of zeros, remember. This is just even number of zeros, nothing else. Okay, this language is even number of zeros. In this language, you have all the strings with even number of zeros. So look at this language. This language is nothing but even number of zeros. Even number of zeros. You can write regular expression for this. 0, 0 whole star. This is the regular expression for C. For option C, this is the regular expression. So that is the reason what will happen, tell me. So that is the reason this C is regular. So remember, this C is regular. Now let me tell you, like, if you're, see the difference you understand, this difference you understand, that W, if this W belongs to some like 0, 1 star, okay, now this is a non-regular, now this is non-regular, okay, now this language is non-regular and non-CFL, non-regular and non-CFL, okay, because here you can easily see, you can prove it using the pumping lemma, using the Mahil-Nerod theorem, you can prove it, okay, but I will not prove it. We have already done this in our lectures, in Go classes theory of computation lectures. We have already proven this language is non-regular. This W belonging to 0, 1 whole star, this language is non-regular. You can prove it by pumping lemma. We have already done that in the class. Okay, pumping lemma lecture is available on the Go classes YouTube channel. You can watch it. I have already proven the proof I have given to you using pumping lemma. This proof I have given to you that this language is non-regular. Okay, so that you can watch. Also you can prove using Mahil-Nerod theorem. Okay, so now, but you can notice that, look at this language W, where W belonging to 0 star. Now this is just even number of zeros, right? Because W is a sequence of zeros. This W is a sequence of zeros. This W is a sequence of zeros. Sequence of zeros followed by same sequence of zeros. So that is your even number of zeros. Okay, so you are getting even number of zeros, that is regular. So finally I can say that in this question, option C is not the answer, because the question is asking for non-regular, but option C is regular. This is a regular. Okay, what about option D? What about this option D? This option D is saying A power n W, A power n W, n greater than equal to 1, W belonging to AB whole star, and W contains at least an occurrence of A. See what this question option D is saying. Look at this. What this option D is telling you. This option D is telling you that you have this language where A power n W you have. The question is already saying that W belonging to A, B whole star. So W is a string over A, B, and the question is saying that n is already greater than equal to n, and number of A's in W contains at least n A's. Okay, this W contains at least n A's. This W contains at least n A's. Okay, again the same thing happens. If you are by hearting the concepts, then you will make a mistake. Okay, if you are by hearting a concept, if you are not understanding the concepts, then again you will make a mistake, because I have seen many students, what they do like this. Okay, A power n, so you have total n A's, and this W must contain at least n A's. So okay, there is comparison. So this is how many students will think that okay, A power n here, and at least n A's must be here. Okay, at least n A's must be here. So there is a comparison. And because there is 1 comparison, 2 comparison, 3 comparison, this type of concepts, many students, you will see this type of concepts many students use, that okay, 1 comparison, 2 comparison, so this is non-regular. So this L is non-regular. Because there is comparison, finite automata cannot do comparison, so this is non-regular. Let me tell you, this is wrong. This complete logic. First of all, this method, like 1 comparison, 2 comparison, 3 comparison, this type of arguments are very wrong, very, very poor arguments. Okay, some language is having 1 comparison, 2 comparison, 1 comparison is not regular, 2 comparison is not CFL. Okay, so this type of arguments are actually very poor arguments. Let me tell you, there are proper methods. If some language is non-regular, you have proper methods. You can use pumping lemma, you can use Mahil-Nerod theorem, you can use. Okay, so there are proper methods. We have already seen in our theory of computation course, we have already seen Mahil-Nerod theorem, pumping lemma. Using those proper methods, you can prove this. Okay, so anyway, this is completely wrong. Okay, so let me just tell you that this is completely wrong. Okay, so this is completely wrong. Now why this is completely wrong? Because before finding the class of the language, First you find the language. Yes or no? Are forget about class of the language. Correct. Forget about the class of the language. Class of language. Like what type of language is this? Regular, non-regular, CFL, non-CFL. Forget about it. Are forget about it. Forget about class of language. First you understand the language. First, at least understand what the language is, what strings you have in the language, what strings you don't have in the language. First, at least understand the language. Without understanding the language, why are you solving the question? Yes or no? Forget about the class. Once you understand the language, then you can easily answer the question. First, you understand what are the strings in this language and what are not the strings in this language. You tell me. Simple question I am asking. Tell me, is this string in the language a power 3 ba? Is this string in the language? A simple question I am asking. You tell me simple question. Is this string in the language? This string on your screen, this string that you can see, is this string in this language L? Is this string in this language L? Remember, n greater than equal to 1. Is this string in the language L? The answer is yes. Because what is this string? Look at this string. This string is A, B, A. This will satisfy all the conditions. This will satisfy all the conditions. This will satisfy all the conditions. Take this n. Take this n. Okay, take n equal to 1. This will satisfy all the conditions. Every condition is satisfied by this string. Yes or no? Is this clear? This string is satisfying all the conditions. Look at all the conditions, they are satisfied. This string, look at this string. Okay, please look at this string. This string is satisfying all the conditions. Take this as W, take this as W, take this as N. Every condition is satisfied. So this string is in the language. Are you getting my point? So you tell me, another question I am asking. Is this string in the language A, B, B, B? Is this string in the language? Does it belong to L? This string, does it belong to L? Look at this string. And simple question I'm asking, does it belong to L? Now the answer is no. Because n is greater than equal to 1. Okay. Because n is greater than equal to 1. So you must take n is greater than equal to 1. Now you can notice, even if you consider this as W, this W does not contain at least one A. Okay, so you can easily see that. This string on your screen, this string does not belong to L. Okay, so finally I can say this string, look at this string, does not belong to L. So finally, now I think you have understood what is happening here. The idea is very simple. The question is saying that A power n, see what the question is saying. The question is saying that you have A power n. Okay, you have A power n. And then you have W. Okay. Now the question is saying that this W must contain n A's. But what is stopping you? Just consider this. Just do this partition. Okay. Just take n equal to 1 always. Just take always n equal to 1. Okay. Just always take n equal to 1. And what you do? Consider this entire thing as W. Okay, consider this entire remaining part as W. So what I am doing? I am doing this. So just always take n equal to 1. Fix n equal to 1. Just always take n equal to 1. And the remaining part you consider as W. Now the question is very simple. This W contains at least one A. Now the question is very simple, that this W must contain at least how many A's? At least one A. This W, this must contain at least one A. So your language, what is your language? Tell me. In your option D, your language is basically starting with A, and then you must contain at least one A. So for that, what you can do? You can write this regular expression containing at least one A. So now you can see your n is equal to 1. You are taking n is equal to 1, and the remaining part you are considering as W. This is your language. And because you can write a regular expression. So what is your language? Can you tell me? Starting with A and containing at least two A's. This is your language. No, this is wrong. A plus B whole star. This is wrong. This is wrong because you can notice that you must have A here. This W must contain at least one A. Okay. This string W, because the question is saying that this string W must contain at least one A. So is this understood that this was your language in the option D? In the option D, this was your language that you have A power n W, where n is greater than equal to 1. W belongs to AB whole star, means W is a string over A comma B, and W contains at least n A's. So is this understood? Is this understood that this is same as, this language is same as A power 1 and then containing at least one A. Containing at least one A. Just containing at least one A. This is your language. So definitely this is regular, right? This language is regular. So you can notice this is regular. Okay, clear? Is this clear to everyone? So very simple that this language is regular. This option D, this will be regular. So the answer is asking for non-regular. So for this question, for this particular question, the answer will be what? The answer will be only option B. Option B will be the answer. Only option B is the answer. Is this easy? Like, see, this is an easy question. All you have to do, just understand the language. Look at option A, B, C, D. For 1 minute, okay, forget about everything else. You have understood the analysis, whatever analysis we have seen. You understood that. Now you tell me, look at these 4 languages A, B, C, D, and you tell me, is this a complicated question? This is a very basic, very fundamental question. All you have to do in this question, you don't even have to do anything. Just understand the language. What strings you have in the language, what strings you don't have in the language. Just understand the language. So you tell me, this question should be put in which category? Like you tell me, like easy, moderate or hard. In which category should we put this? Easy, moderate, hard. And did you make some mistake? Let me know. During the All India Mock Test 2, did you do this correctly? How many of you did this correctly? Okay. So anyway, the answer will be option B. So you can very easily see. Should I give you one variation? Would you like one variation? Let me give you one variation. Okay. One excellent variation. Option D variation I am giving you. This variation can you handle? The variation 1, option D variation 1 and then variation 2. The variation is like this. W contains at most n A's. Okay. Just small variation. This variation 1. So I will not give you the answer. I will give you the answer. Don't worry. I will give you the answer, but in the comments. Okay. In the comments, I will give you the answer. So you can comment your answer. So please comment your answer. Understand the language. Very important. Understand the language and then comment your answer. What answer you are getting? Is this regular or not? This language is regular or not? Should I give you another variation? Should I give you another variation? Another variation is exactly n A's. Okay. So 2 variations you have on your screen. Variation 1, variation 2. So now you tell me. Understood? So comment your answer. Okay. These are the 2 variations. You understand the language first. This variation 1, variation 2. Understand the language. And then you answer these questions. Okay. In the comments, you can answer your, and I will reply. Don't worry. Okay. In one day, I will reply in the comments, I will reply. So you can just comment your answer. Okay. Now let's move on. So let's see this question. Now this is another very simple question from the theory of computation. But before that, you tell me, the last question was easy, right? Yes or no? Okay. So the last question, many students are saying that it was easy. Okay. So now you tell me this one. This is another question from Theory of Computation in Go Classes All India Mock Test 2. Now the question is saying that a class of languages is closed under subset. A class of languages, a set of languages. You have a set of languages. Okay. So there is a set in which you have languages. A class of languages is closed under subset. What it means? It means that if M is in the class, then subset of if L is in the class, then subset is also in the class. Okay. Whenever L is in the class and M is subset of L, then M is also in the class. Okay. So very simple. Now you tell me about this one. Among the context-free, regular, finite languages, the classes that are closed under subset. Tell me about this one. Okay. So did you understand the question? Question is very simple, that you have a set of languages. So the question is very simple, that you have a set of languages. You have a set of languages. There is a class of language. Now the question is saying that it is closed under, when can you say, if this situation happen, like this is a set of languages, let's call it S. In this you have languages, like there is language 1, language 2, language 3 and so on. There are languages. Okay, there are languages. Now the question is saying that this S is closed. When can you say that S is closed? Under subset operation. What that means? That means that if L2 is here, then its subset is also here. Okay. If L2 is here, and let me assume that this M is subset of L2. This M is a subset of L2. Then this M must be here. Okay. Clear? So if this L is here, then its subset also must be here. Very simple. If some language is here, then its subset also must be here. Now you tell me, this statement, is this true for regular languages? Okay. For regular languages, if you have class of regular languages, for example, if you have class of regular languages, then this statement is actually false. Okay, then this S is not closed. Remember, if you have regular languages, then this is not closed. Why? Very easily you can see. For example, you can take sigma star. Sigma star is regular, right? Sigma star is regular. Okay, so its subset also must be regular. But that is not true. For example, maybe this L, consider this M. Maybe this M is your A power n, B power n. N is greater than equal to 1. So you can notice this is definitely not here. So this M is not here. So this is not closed. You can notice. Okay. You can notice. One more thing I am asking. You just tell me a simple question I am asking. If regular languages, if class of regular languages is closed under subset, then what can you say? If class of regular languages, if class of regular languages is closed under subset, then subset operation, then what will happen? Then every language will be regular, right? Yes or no? Correct. Then every language will be regular. Every language is going to be regular because every language is subset of sigma star, which is regular. Right? Yes or no? Is this clear? You can easily see if the class of regular languages is this class of regular languages, if that is closed under subset operation, if this is closed, if this is closed, then every language will be regular. There will be no non-regular language. In this situation, we will not have any non-regular language. Okay. Then every regular, okay. What about this statement? If the class of CFLs is closed, then can I say this statement is true? On your screen, this statement, is this true? If class of, if the question I'm saying, if class of CFLs is closed under subset, then can I say every language will be regular? Can I say every language will be regular? Again, the answer is yes, because sigma star is CFL also, right? Are sigma star is CFL. The reason is very simple, because sigma star is CFL. Okay, because sigma star is a CFL. Sorry, wait a second. If class of CFL is closed under subset, okay, so actually this statement actually does not make sense. So okay, this actually does not make sense. But anyway, let's come. So you can easily see that set of regular languages that is not closed under subset operation. Similarly, you can notice this set of CFLs. You can easily see that this is CFL, this sigma star. You can easily see this is CFL, but its subset is not a CFL. For example, its subset you can take a power n, b power n, c power n, where n is greater than equal to 1. This is subset, you can notice this is not CFL. Okay, so CFLs are not closed under subset operation. Okay, so you can easily see that subset of CFL may not be CFL. So again, CFLs are not closed under subset operation. But finite languages, if you look at set of finite languages, look at this. You have set of finite languages. Okay, all the languages are finite languages. Then its subset also will be finite language. For example, if L is finite language, then its subset also will be finite. Then its subset will also be finite. Its subset also will be finite, right? Yes or no? Very simple. Okay, so very simple that if class of finite languages, they are closed under subset operation. So finally your answer will be only finite languages, class of finite languages that is closed under subset operation. Okay, regular languages are not closed. Context free languages are not closed under subset operation, but finite languages, set of finite languages, class of finite languages is closed under subset operation, because subset of finite language will be finite language. Okay, very easily. So you can see this is easy category, right? This is extremely easy question actually. So far we have seen 3 TOC questions. You tell me, so far TOC questions were easy or not? In the All India mock test, so far we have seen 3 TOC questions, theory of computation questions. TOC was easy or not? Easy, moderate, hard? You tell me. Okay, let's see this question. This is interesting. A very brilliant, like very nice question. A beautiful question from the Berkeley University. Okay. This question has been taken from the Berkeley University, and this is very nice question. So let's see this one. The question is asking, which of the following decision problems is decidable? Okay, which of them is decidable? The question is asking for decidable, remember. So don't make a silly mistake. Don't make silly mistake. This is, I can say, the question is asking for decidable. Now you tell me. First of all, look at the option A. Is this decidable? Option A. Option A is saying that given a context-free grammar over A, B, does G generate all strings of length less than 2023? Is this decidable? Let me know. This option A, is this decidable or not? Option A. Yes, this is decidable. This is decidable. Why? What is the reason this is decidable? See, very simple. Option A, what this option is saying, that given a context-free grammar, G, this G is a context-free grammar. Okay. Does G accept, or I can say, does G generate every string of length less than 2023? Does G generate every string of length 2023? So now you tell me about this one. What about this one? So you can see this is decidable. This problem is decidable. You can write algorithm for this. How will you write algorithm for this? This problem is very easily decidable. What you can do? Very easily, because how many strings are there? How many strings you have to check? Okay, every string of length less than. So how many strings you have to check? Finite number of strings. Finite number of strings you have to check. You have to check finite number of strings. Okay, for example, this 2023 is not needed. You can just take, like, for example, 100. The question will not change. Okay, the logic will not change. The logic is, the concept is not going to change. You can put, so you can notice finite number of strings you have. You need to check finite number of strings. Very simple. So what you will do? Just run every string on the context free grammar. Right? Yes or no? Just run, or what you can do actually, the algorithm you can do like this. The algorithm you can do like this. Very simple. See. What you can do? First, you can convert the context free grammar into Chomsky normal form. Into Chomsky normal form you can convert, right? This conversion. Tell me, for this conversion there is algorithm, right? For this conversion there is algorithm, right? Yes or no? We have algorithm. So for this conversion there exists algorithm. This conversion you can do algorithmically. Okay? With using the algorithm, algorithmically you can do this conversion. After doing this conversion, what you can do? This CNF has a property. What this CNF has a property? In this CNF, if you want to check string W, then how many steps you need to check? Check string W. Then how many? Tell me. Check string W. Then how many steps you need to check? You need to check, I can say, exactly 2 length of W minus 1, these many steps. Right? Yes or no? So you need to check these many steps. Correct? Okay. All you have to do, if you want to check this string, then exactly these many steps you need to run for one string. For one string, you need to run these many steps. Okay. So you have finite number of strings. So just run them. Okay. Very simple. What you do? Just run them. You have finite number of strings. What you do? For all strings W whose length is less than equal to 100, what you do? Just run them. Okay, just check them now. You can check them. Check all of them. So this is decidable, right? Finite number of strings you have. There are finite number of strings, so you can easily check them. Is this clear to everyone that option A is decidable? This option A is decidable because very easily what you can do, there are finite number of strings to check. You have to check only finite number of strings. Okay, you have to check the strings whose length is less than equal to 2023. There are finite number of strings. You have only finite number of strings. So what you can do, all these strings you can just check. You can convert your context free grammar into Chomsky normal form. Okay, for that algorithm exists. There is algorithm for conversion. Context free grammar can be converted to Chomsky normal form. There is algorithm. Then what you can do? You can check every string. All you have to do, just run for exactly 2 length of W minus 1 steps. Then what you can do? Very simple. Finite number of strings you need to check. Just run them. That's it. Okay, just check them. Okay, now let's see. Don't actually, you cannot run the string. I am not saying that. Just check all of them, whether they can be generated or not. Okay, just check all of them manually. Manually you can check. So this is decidable. Okay, after that, you tell me about option B. Option B is saying that just the complement. Option B is just the complement. Like, now you have to decide, does G generate all strings of length greater than 2023? Okay, so what option B is saying? Option B is saying that there is a context free grammar G. There is a context free grammar G. And what we have to decide, this is the problem. Does G generate all strings of length greater than equal to, for example, 100? Okay, for example, 100. Okay, now you tell me, is this decidable? This problem, let me assume that this is decidable, then their problem will happen. See, do you remember? Okay, let's see whether this is decidable or not. You have a context free grammar. There is a context free grammar. Does G generate all strings of length greater than equal to 100? Okay, is this decidable? Assume this is decidable. Okay, just assume this is decidable. Then what will happen? Assume it is decidable. Then a problem will happen. I am assuming that this is decidable. Then a problem will happen. If you assume this, then problem happens. Then problem happens. What problem happens? Then problem happens. What the problem will happen? See, do you remember that this problem is undecidable? You cannot decide sigma star. Like, this problem is undecidable. Like, given a context-free grammar G is LG equal to sigma star. This universality problem, this is undecidable, right? We cannot decide this. Correct? We cannot decide this, right? This is a standard problem. Given a context-free grammar is the language sigma star. This is an undecidable problem. This is undecidable problem. Okay, this problem is definitely undecidable. So if I give you a grammar and then I ask you, is the language sigma star, then that is undecidable. But you notice that now you already know that this, we already know that this is decidable. Okay, like given G, okay, does it contain all strings of length less than equal to 100? Does G contain, or I can say, does LG contain all strings of length less than equal to 100? That is decidable. That we already know. That we have already seen. This is decidable. If you can also decide this, then you can decide sigma star, right? Are you getting my point? Now, if we can decide, if you can decide this greater than strings, okay, if you can decide these also, if you can decide for these also, then what will happen? Then sigma star, then this LG will be sigma star. This problem will become decidable, right? Problem becomes decidable. Yes or no? This problem will become decidable. See, if you can decide whether you are accepting less than equal to 100, and you can also decide greater than 100, then basically what you have decided, tell me. Are you getting my point? Is this clear to everyone? See, if you can decide this, and if you can, like, this is a simple, okay, just assume, given a context-free grammar, you give me, and I am a Baba, let's assume, I am a Jadugar, magician, whatever. So you give me, and you want to decide. What you want to decide? You want one algorithm. You want to decide, is LG equal to sigma star? This is what you want to decide. Now, if I can decide, you come to me. Okay, let's assume you come to me. And let me assume, if this is known that, okay, I can decide this. That, okay, I can say for all, this is simple for me, for all strings of length less than equal to 100. For all strings W of length less than equal to 100, I can decide, right? Okay, I can decide. This you already know. Now, if I can decide for the remaining also, if I can decide for the remaining also, if I can decide for remaining also, then I can decide undecidable problem, right? Yes or no? Then I can decide this undecidable problem. Then I can decide. Then I have decided undecidable problem. That is contradiction, right? Yes or no? Then I decided undecidable problem. So tell me, is this clear? Please let me know. Is this clear that this language is undecidable? The proof, the beauty, the proof is beautiful, right? Simple contradiction proof. The proof is actually simple contradiction, that if you can decide less than 100 also, if you can decide for all the strings less than equal to, whose length is less than equal to 100, if I can decide for the remaining string also, then there is a problem. Then I can decide an undecidable language. Array, something which is undecidable, I can decide that. That cannot happen. So this is the contradiction. Did you tell me? Did you understand? Very simple and beautiful question, right? See, this type of questions you cannot solve using that table. If you by heart that table, do you remember? In decidability, when students study decidability, many students, what they do, they by heart one table. There is a decidability table, they will by heart that table. See, table is fine. From that table, some questions you can solve. Table is fine. But don't rote learn it. Don't by heart that table. Understand that table. In that table, if something is decidable, understand why it is decidable. If something is undecidable, understand why it is undecidable. So do not rote learn the table. Stop the rote learning. Okay, do not by heart the table. Table is very good. Table is fine. Table will help you a lot. But if you by heart the table, it will not help you in the GATE exam. Because, for example, this question, look at this question, option A, option B. From that table, you cannot solve it. Okay. From that table, you cannot solve this question. This is a simple logical question. Option A, option B are very easy. If you notice, for option A, we have algorithm. What you can do? Context-free grammar is given to you, and you have to check, does it generate all the strings of length less than equal to 2023? You have finite number of strings to check. Okay, you need to check finite number of strings. You can check all of them because this is a context-free grammar. You can convert this grammar into Chomsky normal form, and then you can check. Then you can check for all the strings. Manually you can check. So option A is decidable. You have algorithm. There is algorithm for option A. So this is decidable. Now the beauty is option B. Okay. The beautiful question, the beautiful variation is option B. See, if you can decide option B also, then you can decide universality problem for context-free languages. But this universality problem is undecidable. Right? Yes or no? This universality problem, we already know this universality problem is undecidable. This problem, this is called universality problem. What is this called? This is called universality problem of CFLs. Okay. So this is undecidable. So the beauty in option B, what is the beauty in option B? If you can decide for all the strings less than equal to 2023, and if you can decide for all the strings whose length is greater than 2023, then you can decide sigma star. Okay. So that is the contradiction. Please tell me, did you understand the contradiction here? Did you truly, okay, please let me know honestly, did you understand option A or option B? Option A is very simple, but option B is the beautiful. Okay, in option B, we can prove using contradiction. If option B is decidable, then universality problem of context-free languages is decidable. Okay, so this is a very simple question, that option A, option B. So this option B is undecidable, I can say. Okay, this is the proof. I have given to you the proof, the formal proof I have given to you. So remember, this A is decidable, this B is undecidable. And what about the remaining? Given a context-free grammar over A comma B, is the language equal to epsilon? Okay, is the language equal to epsilon? This is also decidable. This C is also decidable. Okay, this option C, this, let me tell you why this is decidable. See, this is also decidable. This, look at this option C. What this option C is saying? This is saying that given a context-free grammar, G is LG equal to epsilon. Okay, so this is actually decidable. How can you decide this? Tell me. This problem is decidable, but how can you decide this? This is decidable, but how to decide this? The decision is very simple. First of all, what you can do? First, you can check, does G generate empty string? Right? First, you check, does First you check, does G generate empty string? This empty string belongs to L of G. First you check this empty string belongs to L of G. And for that, what you can do? Tell me. Does empty string belong to L of G? This is decidable. This is decidable. What you can do for this problem is decidable. Okay, for this all you have to do, just check is S in the empty is the starting variable nullable. Just check, all you have to do, check if start variable is nullable. Okay, all you have to do, just check if start variable is nullable. Is the start variable nullable? Just check that. Nullable algorithm. Okay, yes or no? Nullable algorithm. So you can easily see that this will be your so this is going to be your this is decidable. So first you have decided this, that empty string is in the language. First you decide this. First you confirm this. This confirmation you do, that empty string belongs to L of G. Okay. So this is definitely decidable, and the reason is very simple, because you can check it out. Just check, is the start variable nullable? Okay, look at the start variable and check, is this nullable? Okay, after that, what you need to do, is this enough? A simple question I am asking, is this enough for this problem? For this problem P, is this enough? This is your actual problem P. Is this enough? Is this enough? This is not enough, because we have only checked that empty string belongs to the language, but we need to make sure that nothing else is accepted. Okay, we need to make sure that nothing else is accepted. This is what we need to accept. Okay, so this is what we need to make sure, that nothing else is accepted. So how to make sure that? Now the second thing, you need to make sure that nothing else is accepted. Okay, the second thing, you have to check that G does not accept anything other than empty string. I can say G does not accept any non-empty string. Any non-empty string. Is this decidable? Tell me. G does not accept, this G should not accept any non-empty string. Is this decidable? Yes, this is also decidable. How can you decide? Very simple, very simple. See the beautiful proof. What you do, this is decidable actually. This is decidable. What you can do, all you have to do, okay, this is decidable. All you have to do, what you need to do, let me tell you. All you have to do, just convert this G to CNF. Okay, this G you convert into CNF, and then you check, is start variable useless? Is start variable useless? All you have to check, is the start variable useless? If the start variable is useless, this is what we want. So here you need to check useless. Just check, is the start variable useless? This is what you have to check. So this useless variable, this is also you can check. Okay, remember, G should not accept anything other than empty string. G should not accept any non-empty string. So what you can do, you can convert this to Chomsky normal form. In the Chomsky normal form, you can check that the start variable is useless. If the start variable is useless, then I can say yes, the answer will be yes. Okay, so very simple. So let me conclude this. Option C, let me conclude this. Option C is decidable. And what is the algorithm? Let me tell you. This option C is basically decidable. But let me tell you the algorithm. So the input, what is the input? The input is a context-free grammar. Context-free grammar, G is the input. And what is the problem? The problem is that LG equal to this. Now, in this situation, what is your algorithm? What is the algorithm? The algorithm is like this. First you check, is start variable nullable? Is start variable in G nullable? This is what you do first. This is the first step. You check this. Is the start variable nullable? If yes, then go to step 2. Then go to step 2. And if no, if start variable is not nullable, then G will be rejected. Then G will be rejected. If start variable is not nullable, if your start variable does not generate null, then you should reject G, because start variable does not generate null. So in this situation, rejected G, rejected G. Just reject G. Okay, very simple. So this is your algorithm. Now what is step 2? Let's see. What is the step 2? In the step 2, you check this. Is in the step 2, what you do? In the step 2, you convert this to Chomsky normal form. Okay, this context-free grammar you convert into Chomsky normal form. Okay, and now in this, what you do? You check is start variable useless. Check is start variable useless. Again, if the answer is yes, then accept G. Okay, if the answer is no, then reject G. This is your complete algorithm I have given to you. I have given to you the complete algorithm. Okay. Understood? How many of you understood? Please tell me. How many of you understood? Let me know. Please tell me. How many of you understood? See, one doubt Vijay Raj is asking. Let me take that. One doubt Vijay Raj is asking. Are these two complement of each other? See, in option A and option B. Okay, let's come to option A, option B. Let's come to them. Vijay Raj is asking very nice doubt, but let me answer it. Okay, see, option A, option B. What this option A is saying? This option A is saying that there is a context-free grammar. You have a context-free grammar. There is a context-free grammar. Okay, G. There is a context-free grammar G, and the question is asking, G accepts all strings W whose length is less than equal to 100. And what is option B? Option B is this. Again, you have context-free grammar. G accepts all strings W whose length is greater than 100. See. Very simple. Look at this argument. You know that A is decidable. We have already seen this. There is no doubt in this. I know in this there is no doubt. Okay, in this one there is no doubt. Correct? In this option A there is no doubt. This is decidable. Now Vijay Raj is saying that decidable complement is decidable. Decidable complement is decidable. Okay, this A is decidable. And we know that decidable complement will be decidable. If you have a decidable language, that complement also will be decidable. So A complement must be decidable. This is correct. This is correct. Your language is decidable. This is actually correct. Then what is the problem? See, if language is decidable, its complement will also be decidable. This we already know. That decidable language complement will be decidable. If your language is decidable, if A is decidable, then definitely A complement will be decidable. This is correct. There is no problem in this, Vijay Raj. Is this clear? This argument is correct, but this B is this complement of A. This B is this complement of A. Simple question I am asking. Is this B complement of A? What will be the complement of A? Can anyone tell me? What will be complement of A? If your language A is this, then what will be complement of A? Look at this language. What is going to be the complement of A? Anyone? Please tell me. Let me know. If A is this language, then what is the complement of A? What will be the complement of A? Your language is those context-free grammar who accept all strings less than equal to 100. So the complement will be what? Are. In this language A, we have those context-free languages which accept all strings less than equal to 100. So in the complement, we will have those context-free languages which do not accept some string, of length less than equal to 100. Is this clear, Vijayaraj? Please tell me. Vijayaraj, is this clear? But this A complement will be decidable. That is not a problem. This will be decidable. This is decidable. There is no problem. But option B is not complement of option A. Your option B, look at this option B. This is not complement of option A. Is this clear? This option B, this is not complement of option A. Now, is this clear? Tell me, Vijayaraj, is this clear? That option A is decidable, but option B is not complement of option A. They are not complement of each other. Okay. Complement of A will be decidable. There is no doubt in this. It is very clear. There is no doubt. It is correct that complement of A will be decidable. But option B is not complement of A. Okay. What will be the complement of A? In option A, in this language A, you have those context-free grammar which accept all strings of length less than equal to 100. So these context-free grammar, these people are accepting all strings of length less than equal to 100. So which people are remaining then? In the complement, you will have those people who are not accepting some string of length less than equal to 100. So in the complement, you will have those context-free grammar which do not accept some string, some string of length less than equal to 100. Vijayaraj, is your doubt clear? Please tell me. So this is your option A, B, C. So they are decidable. Option C is decidable. Actually, let me give you one thing. The proof I will not discuss right now. The proof you can find on the GATEOverflow. I have written this proof, but this note I am giving you, you can write this note in your notes. Okay, this important note you can write in your notes, that this problem is decidable. Okay, this problem is decidable given a context-free grammar G and a finite language L is LG equal to L. This problem is decidable. This problem is decidable. Okay, you can write this in your notes. This problem is decidable. The proof is actually very easy, and the proof is similar to what we have seen. For option C, we have seen the proof, right? For option C, I have given you the proof for option C. Similar proof you can apply here. Okay, actually the proof I have given to you. This was goclass's subject test question. Okay, this is goclass's test series subject test question. In the subject test, this question was there, and I have given the proof in the explanation. So if you have goclass's test series, then you must have seen this question with proof. I have given the explanation. Okay, in the explanation, I have given the proof. In goclasses, we do not study anything without proof. Everything that students will study, everything that we teach in every subject, whatever we teach with proof. Okay, we teach with complete, clear and correct understanding. Okay, so this problem on your screen, this is decidable, and the proof I will not discuss right now because I have already given you the proof of option C. But this language, I give this to you as a homework. If you want to prove it, you can try to prove it, or you can remember it. But if you want to know the proof, okay, if you are curious that, okay sir, I don't want to by heart anything, I want to understand what is the proof, then the proof you can find in the goclass's test series. In explanation you can find. Okay, in the explanation I have given the proof of this problem. Okay, so anyway, this is decidable. Now you tell me a simple thing. If this is decidable, then automatically this will be decidable, right? Arey, yes or no? If this problem is decidable, then automatically this will be decidable, because this is a finite language, right? On your screen, look at this. This is a finite language. Okay, so this also will be decidable. Is LG equal to L? This problem is decidable. Okay, look at this. Please look at this. Look at this. This problem is decidable. So automatically this also will be decidable. So automatically this also will be decidable, because this is a finite language. This is just a finite language. Okay, so that's it. So I hope all these questions are clear. So you can see that option C is decidable. What about option D? Given unrestricted grammar, does it generate all strings of length less than 2023? This is undecidable. Unrestricted grammar corresponds to Turing machine. Yes or no? Are unrestricted grammar, that means recursive enumerable grammar, that corresponds to Turing machine. And by the Rice theorem, you can see this. So this problem is undecidable. Look at this option D. What this option D is telling. Let's take option D. Let's take this option D. What this option D is saying? This option D is saying that basically you have Turing machine. Okay, you have Turing machine M, and the question is saying that LM contains all strings of length less than equal to 2023. LM contains. Okay, so this here you have Turing machine. Now your input is Turing machine. Your input is basically Turing machine. Now you can easily see that this you can apply the Rice theorem. You can apply. Okay, containing this is non-trivial property. This is a non-trivial property of RE languages. This is non-trivial property of RE languages. Because this is non-trivial property of RE languages, so L is undecidable. Okay, so this is a simple question. You can just apply the Rice theorem. Okay, by Rice theorem. Here we are applying the Rice theorem. So because this is non-trivial property, except containing all the strings of length less than equal to 2023. Okay, containing all these strings, that is non-trivial property of RE languages. This is non-trivial property. So that is the reason by Rice theorem, this language in option D, that is undecidable. Okay, so finally your answer is what? Tell me, what is your answer? The question is asking for decidable. This is decidable, and option C is decidable. So for this question, the answer will be A, C. What is the category of this question? Easy, moderate, hard. I think we can put this in the category of hard. Okay, right? We can put this question we can put in the category of hard. But let me tell you that it is important that you understand all these logics, because in the GATE exam they will ask you harder questions. Okay, this question of decidability, this is nothing in front of GATE exam questions. In the GATE exam they can ask you anything. If you have correct, complete understanding, okay, if you are understanding the concepts in a right way with proof, if you are understanding the concepts, then the GATE exam will become very easy for you. Okay, so definitely we can see. So this is your question. Just tell me simple thing. Did you understand all the options? Each and every option, did you understand? If you look at this question, okay, forget about whatever we have seen, forget about that. Okay, for a moment, just look at this question and think about it. Option D is undecidable by Rice theorem. So option D is very simple. Okay, all you have to do, apply the Rice theorem. Okay, the Rice theorem you can apply, and option D is basically undecidable. Now you can see option A is very easy question. Option A, that is decidable. You can check for every string. Okay, for every string you can check. You need to check only finite number of strings. So option A is decidable, because the input is context-free grammar. So you can convert this context-free grammar to Chomsky normal form, and then you can check for all the strings. Okay, so very simple. This is decidable. But option B is the beautiful. Actually, this is my favorite question. Let me tell you. Like this option B, this is my favorite question. This is beautiful, right? This option B, this is beautiful, because if option A and option B both are decidable, then the universality problem of context free languages will become decidable, right? Okay, so definitely you can notice that A is decidable, B cannot be decidable, because if B is decidable, then universality problem of context free languages will become decidable. So there is a contradiction, so this is not decidable. Okay, and we have seen option C, we have seen this option C, the proof I have given to you. Okay, the proof is already given to you, so this option C is also decidable. So this is your question. How many of you did it correct in the All India mock test? Is there anyone here who got the correct answer in the All India mock test? Did you get the answer A, C? Okay. Now, after the complete explanation of this, now let's see this question. I think this is the last theory of computation question. Tell me the answer for this one. This is another beautiful question. So let's read this. What this question is saying that suppose that you live in one dimensional world. Okay, you are living in one dimensional world. Okay, your house is at the position 0. This is your house at position 0. Okay, now what you are doing, one day you decide to go for a walk. Okay, you are deciding, like one day you are deciding that you will go for a walk by taking steps of +1 or -1 forward, backward. So you can go one step forward, or you can go one step backward. Okay, so very simple, you can go one step forward or you can go one step backward, right? You begin at your house, you are beginning at your house, and after completing the walk you are coming back to your house. See, you will start here, you will go, 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 and you will go, but ultimately you come back. Okay, ultimately you come back, you start at your house, then you take 3 steps, then you can take some more steps here, then you can take some more steps here, then you can take like this, but finally you should come to your house. Okay, this is the question. Now what the question is saying, the question is saying that basically you are going left or right, right? Yes or no? What the question is saying, you can go either left or right. Either you can go right or you can go left at any point. At any point, if you are here, okay, at any point, if you are here, either you can go to right or you can go to left one step. Either you can go to right or you can go to left one step. This is given to you. This is given to you, either left or right one step, either left or right. So that is your alphabet. That is your alphabet. What is a string? A string is basically possible walk. How many walks you are doing, how many walks you are doing, that is a string. But in your language, what you have, look at this language L. Look at this language L. What this language L is saying, please understand this language L. This language L is saying that those strings means those walk, those strings, okay, where you are starting and coming back to your house. Okay, where you are coming back to where you started. Like if you start here, then you are coming back here, you are coming back here, because the question is saying you are starting at your house, so you come back here. So can anyone tell me what is this language? In this question, all you have to do, just understand the language. Your alphabet is left comma right. Your alphabet is left comma right. Okay, what is your language? Language is basically those strings of left comma right, such that you start and end at same point. Okay, those strings where you start and end at the same point. Start point is same as the end point. Start point is same as the end point. Which strings we have in the language? Tell me. Arey, when can you start and end at the, like let's assume this is your starting point. This is the starting point. When can you go back, come back here? Like you are going right, then you are going right, then you are coming left, then you are going, and so on. So when can you come back? For which string you can come back? Tell me. Simple question I am asking. This is your starting point. Please understand. For example, you can take right, then you can take another right. Okay, then you can take left, then you can take left, then you can take another left. So you will come back. So in this language, this RRLL will be there. you are coming to the home, starting and ending point is same. Okay, now you can notice that, or what you can do, you can go one step right. See, you can go one step right, then you can go one step left, then you can go one step left, then you can come back one step right. So this string right left right left left right, this is also in the language, this is also in the language, and this is also in the language. Like, what you can do, you can go to right, then you can go to left, then you can go to right, then you can go to right, then you can go to left. So right left, this is also in the language. Can you see what is the language? Can you see what is the language? Please tell me. You are starting, this is your start point. Start point must be same as the end point. So what you need to do, what you need to do, very simple, number of L in W must be equal to number of R in W. Number of L, how many left move you make, how many right you move you make, they must be same. Left move, right move, they must be same. Then you will come to start point will be equal to end point. Yes or no? This start point will be same as end point. This start point, this is going to be same as end point. When it will happen? When it will happen? When you have equal number of L comma. So this is your final question. Your question is basically, a language is given to you where you have equal number of A and equal number of B. You can understand like this. You can understand like this. Number of A in W is equal to number of B in W. This is your language. Now the question is asking for which of the grammar, tell me, which of the following grammar will generate this? Some options are given to you. First, you understand this language. The question is just saying that this is your language. All you have to do this. This is all you have to understand. This is all you have to understand from the question. The question is saying that you are going left, right, left, right, left, right, left, right. You are coming back. You are coming back. Okay. You are coming back at your house. You start at your house. At your house you start. You go left, right, left, right, left, right. You come back. Then what it means? It means that number of left moves is equal to number of right moves. Is this clear? The number of left moves is going to be equal to number of right moves. This is your language. So your language is number of A's equal to number of B's. This is the question. Please tell me, isn't it like, I don't know, like I find this the beautiful question. See this information on your screen so far. Look at this information. Look at this information. This information is telling you, that L is number of A equal to number of B strings. You have those strings where number of L will be equal to number of R. This is this paragraph, the entire paragraph, this photo, this whatever details are given to you. The complete question, if you read, then what you will see? You will see this is the language. Now the question is asking, which grammar will generate this language? Sorry, does not generate. The question is asking, which grammar does not generate this language? Okay, so let's see option A. Tell me about option A. Let me take one by one. Option A, is this grammar correct? S goes to A as B, B as A, epsilon. Is this correct? Is this grammar correct for this language? Tell me. On your screen, you have this grammar. Is this grammar correct for this language? So this is clearly wrong. Okay, this grammar, see, first of all, this grammar cannot generate starting with A and starting with B, ending with A. Array, this grammar cannot generate what? This grammar cannot generate this type of string. This type of string cannot be generated, but they should be generated, right? This type of string, they should be generated, correct or not? They should be generated. They should be generated. LLRR is generated. LLRR, that is generated. See, this is generated. AABB, this is generated. Sorry. Sorry. AABB. Okay. Yeah, this is generated actually. This is generated. But you can notice ABBA, that is not generated. Is this clear? Okay. So definitely this grammar is not the answer. Definitely. The question is asking which does not generate. Does not generate. So this does not generate. This option A does not generate. But this is not the complete analysis. You give me the complete analysis. What is the language of this grammar? Anyone want to tell me what is the language of this grammar? Anyone here want to try what is the language of this grammar? What language this grammar will generate? This context free grammar. This is your context free grammar. What this language will generate? You can notice that this will generate this type of string. If you are starting with A, then the last symbol must be B. Okay. If you are starting with A, then the last symbol must be B. If the second symbol is B, then this symbol must be A. If this symbol is B, then this symbol must be A. Similarly, you can notice if this symbol is B, then this symbol must be A. Like this it is happening. So no, it is not palindrome. It is like I can say it's something like this. So for example, if you have ABB, then you must have this must be B, this must be A, and this must be A. So something like this. Actually, what is this? Let me tell you what this language will generate. This will generate this type of W reverse complement, right? Are yes or no? This will generate this type of strings. Is this clear? Option A is S goes to A. If you are starting with A, then you should end with B. If you are starting with A, you should end with B. If you are starting with B, you should end with A. Okay. So what is the language generated by this? The language is generated will be like this. You have W, then W reverse, but its complement. Change A to B, B to A. It's like, for example, it's like this. If your W is this, A, B, B, A, B. If this is your W, then what your W, first you find W reverse, then you complement the symbols. Okay, if this is your W, then what will be W reverse whole complement? So that will be like you reverse it, but you complement, like change this A to B, change this A to B, change this B to A, change this B to A, then something like this. Okay, so this is definitely not the answer. What about option B? What option B is saying? That is saying LRS, RLS. Okay, what is this option B is saying? Option B is saying that S generates ABS, BAS, this. This is also not the answer. Why? See, this is also not the answer. What is the reason? This is also not the answer. What is the reason? The reason is very simple. Because you cannot generate this type of strings. This type of string you cannot generate. But you should be able to generate. Right? Yes or no? You cannot generate this type of string. But you should be able to generate. This belongs to the language. So this is your method 1. But there is a smart method. Can you give me a smart method? What is the smart method? Something smart. See, this is non-regular, right? Are yes or no? This is non-regular. This language is non-regular, correct? Look at this language L. This is non-regular. But the grammar is regular. The grammar is regular. So this can never be the answer. Look at the grammar. The grammar is regular. Right linear grammar. This is right linear grammar. This is the right linear grammar. So this is definitely not the answer. So this option is definitely not the answer. Okay, so you can notice this LB is definitely not same as L. Isn't it smart? Like something smart. That your language is non-regular. Number of A equal to number of B. Your language is non-regular language. This is a non-regular language. But your grammar in option B, that is a regular. Your grammar is regular grammar. That is a right linear grammar. You can notice this is a regular grammar, right linear. So definitely this is not correct. But what is the language? What is the language of this grammar? Can anyone tell me? What is the language of this option B? What is that? Language of option B, can you tell me? Let me know. What is the language of option B? See, this is very simple. What languages you have? So you have like ABS, they will come together. They will come together. So the answer ABS, BAS, epsilon, it's like these two people will come together, then S. Then you can put anything else. Then these people will come together. You can put them in any order. So it's like this: AB or BA whole star. Okay, so your language will have this type of strings. Your language will have this type of strings where A, B are coming in pair. A, B are coming in pair. A, B are coming in pair. This type of strings you have. Is this understood? Yes, very good. So this is your language, because you can notice that AB is coming together. This AB will come together, then this S can generate anything. This BA will come together, then this S can generate anything. So that's like AB plus BA whole star. Okay, this is also not the correct. So you can notice that this also does not generate. The question is asking for does not generate. This also does not generate. What about the next option? What about the next option? LR. Okay, it's like ABS, ABS, BA. So what is this? Look at option C. Let's check option C. You tell me what about option C? What this option C is saying? Option C is saying that ABS, BA or BAS, AB or epsilon. Now you tell me. What about this one? Is this the answer? Again, this is not the answer, because in this word you cannot generate C. In this word you cannot generate. Look at this. You can easily see you cannot generate this string. AB, AB. This string you cannot generate. Correct. AB, AB. Because if you start with A, it will end with A. If you start with B, it will end with B. So this string you cannot generate, but this should be generated. This string you cannot generate, remember. Okay. So this string cannot generate. So you can easily see that this will, this is not the correct. So I can say option C. You can easily see that a language on option C, that is not same as L. That is not same as L. But what is the language here? Can you tell me? Can anyone tell me what is the language of option C? What is that? Anyone here who want to tell me what is the language here? What is the language here? See, it's like AB, then it's reverse. Okay, understand the language. The language is like this. If you start with AB, then its reverse must be here. Then its reverse must be here. Then again, if you have AB, then its reverse must be here. Okay. Then if you have, for example, if you start with BA, then its reverse must be here. Are you getting my point? Is this clear? So actually, what is the language here? Okay, something beautiful is coming. The language is something like this. The language is WW reverse, where W belongs to AB plus BA whole star. Where W belongs to AB plus BA whole star. Okay. See, the language will be, it's like the W will be AB plus BA whole star, then it's reverse. Is this clear to everyone? Let me know. Beautiful language, beautiful. See, WWR, there is a reverse. This is your W. This is your W reverse. Okay, so W reverse, but W belongs to AB or BA whole star. Okay, W will be AB or BA whole star. This is your language in option C. What about option D finally? So this is also not correct. You can see that this option is also does not generate. So this is also not generate. What about option D? What about this option D? This will also not generate actually. This will also not generate. The question is saying SLR. Okay, so let me give you what this option D is. After this option C, what this option D is. This option D is something like this. S ABS or SBAS or epsilon. Tell me, is this correct language? Is this correct? So again, this is not correct because you can easily see that they will come in pair. They will come in pair. You cannot generate like something like this. Something like this you cannot generate. AABB. This you cannot generate. You cannot generate AABB. This type of string you cannot generate AABB. Okay, very simple. So this is also, so your answer you got right. You understood that answer is this does not generate, this does not generate, this does not generate, this does not generate. So they do not generate. So your answer will be A, B, C, D. They do not generate. The question is over. The question is clear, right? See, the question is actually very simple. If you notice, look at this question. Look at this question. The question is saying that in this question, if you read the question carefully, then you will find that the language is equal number of L equal number of L and R. Number of left move equal to number of right move. Okay, how many left move you make, that must be same as how many right move you make, so that you can come back to the same place. If you start here, you should come back here. Okay, so that is the reason the language is equal number of L and R. Now you can easily see that the question is asking which grammar does not generate this language L. So you can notice all the string, all the grammar, each grammar you can notice they do not generate L. This was your question. Okay, what is the language of option D? Can anyone tell me? What is the language of option D? For option D, what is the language for the option D? You can again notice a small thing will tell you that basically again they are coming in pair. AB, BA, they will come in pair. The language again will be AB plus BA whole star. They are coming in pair. You can check it out. Okay. These people are coming in pair. AB, BA, AB, BA, AB, BA. Okay. So they are coming in pair. So the language will be AB plus BA whole star. This is your language. Okay. Then what is the language then? See, all the four grammar that are given to you, these are not correct. Then what is the correct grammar for this language? This is a context-free language. What is the correct grammar? This is a context-free language, but give me the correct grammar for this. What is the correct grammar for this? Can you give me a correct grammar for this? For this one, can you give a correct grammar? Yes, of course, you can easily give a correct grammar. See, the standard grammar you can see, you can give like this. Let me give you. The correct grammar you can give like this. See, if A is coming, then B should come, because number of A should be equal to number of B. Okay. If A is coming, B should come, because it is easily see, if A is there, then B will be there, because number of A should be equal to number of B. Remember. Okay. So number of A should be equal to number of B. So if A is there, then B should be there. For every A, there should be a B. But you remember, something like this can happen. Like for every A, B should be there. For every B, A should be there. But here also you can have something like this. Here you can also have for every A, B should be there. For every A, B should be there. For example, here you can have B, for every B, A should be there. For every A, B should be there, and so on. So how can you generate this type of things? See, this you can generate using these two. Like 1, 2. Using 1, 2, you can generate this. Using 1, 2, you can generate this. Using 1, 2, you can generate this. But how to generate this complete thing? Tell me, anyone want to tell me how to generate this complete thing? How to generate this complete thing? Anyone want to tell me? Anyone want to give me suggestion? See, this you can generate by 1 comma 2. This is your 1, this is your 2. This you can generate by 1 comma 2. This you can generate by 1 comma 2. But how can you generate the complete thing? Are very simple. Just put SS. Just put SS. Then you can generate whatever you want to generate. Then you can generate whatever you want to generate, right? Just put SS. That's it. This is your grammar. This is your grammar. Okay. So for this language, remember, there are two standard grammars. Of course, there can be many grammars. You can write many grammars, you can write. But there are two standard grammars. Let me tell you, W belonging to AB whole star, where number of A in W is equal to number of B in W. For this, what is the grammar? For this, the grammar, there are two standard grammars. Let me give you G1. The grammar is like this, that S generates, for every A you should have a B. For every B you should have a A. Then you can generate, remember, you can generate this S as epsilon. So this grammar is correct. Also, this grammar is correct. You can check it out. I leave this to you because we have already seen this in our course. AS, BS or BS, AS or epsilon. This is also correct grammar. So these are the correct grammars. These are the standard grammars for this language. This is the complete analysis of this question. Please tell me, did you understand and what do you think about this question? Did you don't worry about in the exam, in the All India mock test, did you do this correct or wrong? Don't worry about that. Okay. In the exam, whether you did it correct or you did not do it correct, do not worry about that. But tell me, did you understand the question? Two things you tell me. Did you understand the analysis, the complete analysis? Did you understand? And now you tell me, what is this is a beautiful question, right? So let me tell you, this question is taken as it is. Okay, this question is taken from Stanford University. So this is actually Stanford University question. This beautiful question was there in the Stanford University. Okay, so this question is taken from Stanford University. So you can see, very beautiful question. Okay, if you do the analysis of this question, you will find that this is a very beautiful I can say. So all the grammars, the question. So this is a Stanford University question. Okay, so let's move on. Okay, so these one last theory of computation question we have. So let me solve that also. Let me solve this question also. In the All India mock test, the formatting was not correct. So that is the reason marks were given to all. Okay, is this clear? So when you were attempting this All India mock test, Go Classes All India mock test 2, at that time the formatting of this question was not proper. So that is the reason we have given marks to all. You can check it out. Okay, marks to all has been given. But the question is beautiful actually. What the question is saying, you can read the question, but let me explain. Okay, you can just spend some time and you can read the question. The question is basically saying that you have a string. In that string you have positions. You have a string. In that string you have positions. For example, this string has 5 positions. Okay, for example, you can notice this string AB, this string AB, this has 5 positions. Position number 1, position number 2, position number 3, position number 4, position number 5. So this has 5 positions. Okay, then this predicate is given to you. This predicate is given to you QAX. It means position A has symbol A. Okay, in the position A you have in the position X you have symbol A. For example, here in the position 5 you have symbol B. So that is true. For this string, this is true. For this string, this is false. Like in the position 4 you have B. This is false. Right? So this is your question. Now the question explanation is given to you. Okay. Now what the question is saying, this language is described by the first order logic. Isn't it beautiful? The language is described, the description is given, by the first order logic. This is the beauty of this question. Let me tell you why this question is beautiful, because the language is given to you, language described by first order logic. Using first order logic, the language description is given to you. Isn't it beautiful? This is a brand new question. Of course, this is also a standard question, but this is very, like I can say, very beautiful question, because using first order logic, this first order logic expression is given to you, and the language is described. This language is described. Strings in this language are described. All the strings in this language, they are described by this first order logic expression. What this expression is saying? This expression is saying that, so what this question is saying? This question is saying that W, in this language you have strings W, where W satisfies first order logic formula M. Okay, this is your language, right? Please tell me, isn't it like beautiful question? Isn't it a new question, a brand new question? Okay, you may or may not have seen. I think you did not see this question. This is the first time. I think you might have seen this question, but this is a very brilliant question. This I found in IISc assignment. Let me tell you, this question, if you want the source of this question, the source of this question is IISc assignment. Okay, so this is Indian Institute of Science. This is my college. Okay, so this is IISc question. Actually, this was in my assignment when I was in automata theory course in IISc. This automata theory course I took. Okay, in that course, this question was there in the first assignment. Okay, so if you go to IISc, I hope you go to IISc, IIT Bombay, IIT Delhi, all these brilliant colleges. Okay, IIT, IISc, TIFR, CMI, ISI, IIIT Bangalore, IIIT Hyderabad, DTU. Okay, there are many beautiful colleges. There are many brilliant colleges. IIIT Delhi. Okay, so you can see that this question was in the automata theory course. Okay, if you go to IISc, take the automata theory course, and in the first assignment, this type of question you will find. So this is a beautiful question. I thought that I should put it, because remember, in the GATE exam, maybe someday they can ask you this question, because anyway, this is a IISc question. Maybe that IISc professor, okay, automata theory professor of IISc, the name is Deepak D'Souza, by the way. Professor Deepak D'Souza. Okay, so my name is also Deepak Poonia, but anyway, so Professor Deepak D'Souza, okay, maybe someday maybe they can give this question in the GATE exam. Okay, maybe someday this question can come in the GATE exam. Okay, so that day you can say that, okay, in Go Classes test series, this question was there. If this question comes maybe next year, or maybe okay, this year, next year, or after 10 years, if this question comes in the GATE exam, if this type of question comes in the GATE exam, then you can say that in the Go Classes mock test, this question was there. Okay, so anyway, let's see. This question is not complicated, let me tell you. Let's see the solution. You will see that this question is very simple and beautiful question. This is not complicated question. What this question is saying? The question is saying that W, such that W satisfies first order logic formula. This first order logic formula is given to you. Okay, and W satisfies this first order logic formula. What is this formula that is given to you? Look at this. Look at this formula. This is for all x. What this question is saying? This question is saying that for all x, what will happen? This will happen that if on x position you have A, then if, remember, this x is positions, the domain is, this is basically positions in W. Okay, so these are the positions in W that is given to you in the question. It is given in the question. Okay, every information is given in the question. That is the reason I am calling this beautiful question, because all the information is already given in the question. Domain of variable x comma y is set of positions, So this x comma y, the domain is set of positions. Now you can notice that you have this formula for all x. If on position x you have A, then there exists a position. Okay, there exists a position which is greater than x, this position is greater than x, and this position is greater than x, means this position is right to x, like this x is here, then this position is here. Okay, this position is here, so this position is greater than the position of x, and on that position you have b, on that position you have b. Did you understand this statement, what this statement is saying, what this first order logic statement is saying? Did you understand? Let me explain. Very simple, yaar, very simple. Look at this and please try to understand. Very simple. This is saying that for every position you are saying, for every position you are saying that if A is in that position, okay, if A is in that position, then there is some bigger position. If A is in that position, then there is some bigger position, then there is some bigger position on which you have B. So can I say that this language, can I say W satisfies first order logic, W satisfies first order logic formula M? Can I say it means that in W, every A, please understand, every A is eventually followed by B, is eventually followed by a B, isn't it? Tell me yes or no. Not immediately, there is no need to for immediately, like this is not saying that immediately x is, y is greater than x, y is greater than x, so eventually followed by B, every A, okay, please understand, every A is eventually followed by B, every A is eventually followed by B. So what are the strings then, what are the strings in this language L? Understood? So tell me, what are the strings in this language L? Anyone? Try. So what are the strings in this language L? Every A is eventually followed by B. Like, okay, so basically in this language you have this type of strings. If you have A, see, B does not matter. Every A, if you have A, it should be eventually followed by B. Okay, in between you can have anything. Every A must be eventually followed by B. Every. Okay, so again, if you have A, it should be eventually followed by B. So this type of strings you have. Okay, something beautiful is coming now. Now something is beautiful coming. This L is basically ending with B. Are yes or no? Can you end with A? Tell me. Can we end with A? Can we end with A? Can we end with A? The answer is no. The answer is no. You cannot end with A because every A is eventually followed by B. Every A will be eventually followed by B. Okay. So definitely you cannot end with A. Yes, you will end with B. And every string, so you will end with B. You will end with B. And every string which ends with B is in L. Every string ending with B is in L. Every string ending with B is in L. Yes or no? If you are ending with B, then it automatically belongs to L, right? Because if you have some A that is followed eventually by B, isn't it? Okay. The analysis, did you understand? Like, basically you will end with B. So this language that is given to you, okay, W satisfies, this language that is given to you, W satisfies first order logic formula M. Okay, W satisfies first order logic formula M. Okay, that is basically same as ending with B. This is your answer. This is your answer. The question is asking how many states in the DFA. The question is asking how many states in the DFA. So tell me, how many states in the DFA? How many states will be there in the DFA? So the answer is going to be 2 states. 2 states in the DFA. You can create a 2-state DFA. You can create. You should end with B. Okay, you should end with B. Okay, you should end with B. So this DFA you can create. So the answer is going to be 2. For this question, the answer will be 2. Okay, the answer is 2. Please let me know, did you like this question? Did you did you see in which category you will put this question? Easy, hard, or moderate? Tell me. After the complete analysis, after I told you the solution, I have given you the complete analysis. Now you tell me in which category you will put this question. Is this easy, hard, or moderate? Like, did you love this question? I see this is like one of my favorite question in this test. In this All India mock test, yes, AAB is in the language. Yes, that's correct. AAB, that is in the language, because every A is eventually followed by B. Gaurav, AAB will be in the language. See, Gaurav, AAB will be in the language because every A is followed by B. Every A is followed by B. Every A must be followed by B. Yes or no? Okay. Please tell me. Arey, forget about marks in the test, yaar. Okay. Sometimes you feel happy when you learn something beautiful. Okay. Appreciate the beautiful questions. Appreciate the new questions. Appreciate the questions which improve your knowledge. Did this question improve your knowledge? Just tell me simple thing. In this question, you have first order logic, you have language, TOC and first order logic. First order logic and TOC combined. Okay. So did you like from this question some knowledge did it improve? Like I can say, did it open your mind to some new possibilities? Simple question. Did this question open your mind for some new possibilities? Like there are connections between TOC and first order logic. There are connections, right? Some new possibilities in your mind did you get? Okay. So this observation you make, that there are connections between languages and first order logic. Okay. These connections are there. Okay. So let's take some variation. That is not enough, right? Solving the question is not enough for us. In Go classes, solving the question is not enough. You should also do the variation. Okay. You should also do the variation. So let's do some variations. Let me do some variations. So can you try this variation? Actually, my mobile is going to be switched off. Okay. It is about to get switched off. So I will not be able to see your messages. So this is the last thing we will do in this. Then we will continue. Don't worry. Sachin will continue the his subject. After this session is over, then Sachin will continue All India Mock Test 2 solutions for his subject, like operating system, compiler design, engineering mathematics, algorithm, data structure, computer network, etc. Okay. So anyway, so let me ask you some variations we can ask. Okay, how will you describe this language? Having exactly one A. Having exactly one A. How will you describe this language? Having exactly one A. How are you going to describe this language? Describe using first order logic. Describe using first order logic. Using first order logic. So the question is simple, that your alphabet is A, B. So can you describe this using first order logic? This language having exactly one A. Exactly one A. So what you will say? Are very simple. Having exactly one A means at some position you must have A. So there must exist a position where you have A, right? Correct. There must exist a position where you have A. Where you have A. There must exist a position where you have A and exactly one A. So for the remaining positions, what should happen? Are simple questions I am asking you. So you just tell me the answer. See, how having exactly one A means this type of scenario. Okay. So there should be position where you have A. There should be a position where you have A. And for all the remaining positions, what should happen? For all the remaining positions, if x is not equal to y, then you must have B. That's it. Isn't it beautiful? this variation. So did you understand this variation? Just tell me yes or no. Did you understand the question? Did you understand this variation? A simple variation I am asking you. Okay, is this clear? Okay, so very simple. This type of variations you can create. Okay, and one more variations maybe I can ask. One more variation if you want. Your string, your alphabet is A comma B, and your language is A star. What? How in the first order logic? How will you describe in the first order logic? Describe in first order logic. Describe using first order logic. How will you describe using first order logic? So basically A star, it means everything must be A, right? All the positions must be A. All the positions, every position, every position. So for all the positions, you are saying they must be A. All the positions must be A. All the positions must be A. Okay? So you can see this is your answer. All the positions must be A. So remember, this is your position. Some position must be A. The remaining positions must be B. So this is your complete analysis of this question. Now don't try more variations, because actually see uh, uh, see, regular languages you cannot describe all the regular languages. Some regular languages you can describe. This is actually advanced stuff. I can say this is advanced. I can say this is advanced stuff. Okay, this is advanced stuff. So let me tell you, this you will study in ISC Automata Theory course. In ISC TOC course, you will study this. If you take this course, you will study this, that this is advanced stuff, that some regular languages you can generate, some regular languages you can describe using, some regular languages. Remember, some regular languages you can describe using first order logic. Okay. And all regular languages you can describe using monadic second order logic. So don't worry, this is not in the GATE syllabus. This is called monadic second order logic. Okay, so all the regular languages, some regular languages you can describe using first order logic. Some. Okay, remember, some regular languages you can describe using first order logic, and all the regular languages you can describe using monadic second order logic. Of course, these things are advanced, very advanced. Okay, very advanced things. But a simple question can be asked. For example, this type of simple question they can ask you, right? Yes or no? As you can see, this type of simple question they can ask in the GATE exam. They can give you the details. They can give you all the details, and they can ask you this type of question. Do you agree with me? Okay, tell me. This is very, like, I can say GATE level exam. This is GATE level question, right? After the analysis, once you have seen the analysis, once we have done the complete analysis, can you see that this is very much GATE level question? A simple formula is given to you. You just have to find the language. Okay, you just have to find which strings will satisfy this formula. So this type of question can be created in the GATE exam, where they can define everything. Okay, so some variations I have given to you. More variations you don't have to try. Okay, so I think actually now I think that is enough for today. So after this session is over, then we will schedule the next session where Sachin will take his subject. Okay, all the TOC questions are over. I will also take the remaining. Don't worry, I will take I will also take discrete mathematics questions. I will also take DBMS, computer organization, okay, COA, DBMS. All these questions I will take, but not in this session. This session we will terminate here. Okay. In this session, what we have seen, TOC questions we have seen. Okay. In this session, we have seen all. In this session, we have seen all India mock test 2 TOC questions. Okay. All TOC questions are done. Complete analysis we have seen. complete analysis with variations. This is what we do in the Go classes. This is what we do in Go classes. For every question we do the complete analysis with variation, with proof. We do the complete analysis with variation and proof. Let me tell you, this is what we do in the Go classes. This is the property of Go classes. This is the definition of Go classes. This is the property, or I can say this is the definition of Go classes. This is how you can define Go classes, that in the Go classes we will do complete analysis with proof, with variation of every question, whatever question we solve, whether it is gate question, standard question, whatever question we solve, whatever concept we study, we always study with proof, with variations, with complete analysis. This is the definition of Go classes. Okay, so thank you everyone. I hope you loved all the questions, all the TOC questions. I hope you loved. So please share your feedback. Okay, please share your feedback. So please let me know, did you love all the TOC questions? Total 5 or 6 TOC questions we have seen in this All India mock test. Total 5 or 6 TOC, theory of computation questions we have seen. Did you love all the questions? Please tell me, did you understand all the questions, the complete analysis, all the variations, everything? Did you understand? And if you loved it, then please share your feedback. Please write your please write your feedback in the comments. Okay, your comments we will read. Each and every comment we read. Remember, on the Go Classes YouTube channel, whatever comment you put, we always go through that comment and we will consider your feedback. So please let us know your feedback in the comments. And also, do you want All India Mock Test 3? A simple question. Do you want All India Mock Test 3? Tell me. Do you want All India Mock Test 3? Should we conduct All India Mock Test 3? Go Classes All India Mock Test 3. Do you want that? So you can share your feedback in the feedback video. Go to the Go Classes YouTube channel. There is a All India Mock Test. So please comment your feedback. Okay, please comment. Please comment your feedback. Please comment your feedback on All India Mock Test 2 feedback video. Okay, so please comment your feedback. Your feedback you comment on All India Mock Test 2 feedback video. This feedback video is available on the Go Classes YouTube channel. Okay, so go to Go Classes YouTube channel. You will find this All India Mock Test 2 feedback video. You will find. Go to the live section. Okay, on the Go Classes YouTube channel, go to the live section. You will find this All India Mock Test 2 feedback video, and there you comment your feedback. If you want All India Mock Test 3, okay, depending on your feedback, we will go through all the feedback. Okay, our complete team. I will go through all your feedback. Sachin and Arjun sir. Okay, Arjun sir. So we will go through your feedback and we will decide. We will decide whether to conduct All India Mock Test 3 or not. So if you want All India Mock Test 3, please comment your feedback on the All India Mock Test 2 feedback video. That video you can find on the Go Classes YouTube channel. Go to the live section. Okay, on the Go Classes YouTube channel, just go to the live section. Okay, there you can find the feedback video. Please comment. The comment is very important because so that we can read all your comments at the single place. Okay, so at the single place, if you put all your feedback, all your comments, then our team will go through this. Our team will go through your feedback and we will consider. Okay, so thank you everyone. Thank you so much. Okay, like and share the session with everyone. And if you are a GATE 2025 aspirant, then you can join our GATE 2025 course. Okay, so this Go Classes, if you are GATE 2024 aspirant, if you are preparing for the GATE 2024, then let me tell you, if you want the best preparation, if you want to study the concepts with proof, with complete analysis, with complete understanding, complete clear in-depth understanding, if you want, then you can join Go Classes GATE 2024 complete course. You can join. Okay, the link you will find in the description. So check the description, you will find the link and you can join our GATE 2024 complete course for the best preparation of the GATE exam. Similarly, if you are GATE 2025 aspirant, then you can join our GATE 2025 complete course. The link you will find in the description. Also, if you want to attempt more such quality mock test, Okay, more such quality mock test if you want to attempt this type of gate worthy mock test, all these 15 mock test if you want to attempt, then you can subscribe for mock test package. The link is in the description, so you can check out the description. Go to the description, you will find this link. Go to this link and you can subscribe for all the 15 mock test. Before the gate exam, you can attempt all the 15 mock test. You can attempt all these 15 mock test. Let me tell you, these are the gate worthy, these are the gate worthy best quality mock test. Okay, so thank you everyone, see you tomorrow. Thank you. Gate aspirant is asking, sir, I missed all India mock test 1, can I attempt it? So you can attempt it, but you will have to subscribe for the go classes test series, or you can subscribe for this mock test package. Either you can subscribe for go classes test series, complete test series, or you can enroll for the mock test package. All the 15 mock test you will get. In those 15 mock test, all India mock test 1 is also there. Okay, this AIMT 1, AIMT 2, these two AIMT are part of those 15 mock test. Okay, so if you want to attempt all India mock test 1, then you can subscribe for the mock test package. In that package you will find all India mock test 1, all India mock test 2, and there are many other mock tests. Okay, total 15 mock tests you will find.